Hello and welcome to today's webinar on an introduction to Metashape and StripAlign for TrueView EVO. We just have a few more people logging in, so we're just going to wait a minute and then we'll get going. So thanks for your patience. Okay, let's get started. Again, welcome to our webinar today on an introduction to Metashape and StripAlign for TrueView EVO. My name is Martin Flood. I'm VP of Special Projects here at GRQ Group. I'm going to be moderating the webinar today, but my colleague Derek Wag is going to be doing most of the heavy lifting. He'll be walking us through a demonstration of both these two new products in TrueView EVO. A little bit of housekeeping first, just a quick audio check. Please use the raise your hand button. Make sure that you guys are hearing me. Looks like we're in good shape. We've got audio, we've got video, we're good. Now, the webinar today is scheduled for 60 minutes. We do have a question and answer chat box available. It should be there on your GoToWebinar dialog box. So do feel free to ask questions as we go through the webinar. Just type them in the chat box and we'll try to get to those during the webinar, or we'll stop and have some time at the end for Q&A. As I mentioned, we're scheduled for an hour today. We are recording this session and you will get a link to the recording after the webinar so you can review it or share it with your colleagues. So let's jump right in. MFE and SAFE, or SAFE, Metashape for EVO and StripAlign for EVO. What are they? Where do they fit into your EVO workflow? So if we look at the overall EVO data processing workflow, and many of you have been doing this with your TrueView systems. Once you come back from the field, once you've collected the data in the field and downloaded or imported that TrueView data to create your project, there's some standard steps that you go through to process through to get your colorized point cloud and do any of your additional value add work that you want to do. There are 3 steps in this workflow that steps that are purple here on this work through, where we work with an EVO extension. One you're very familiar with, and that's with PausePack. So with the Planex's software for doing your refined trajectory and from calculating your refined trajectory for your flight. That's a standard part of what you've been doing. The 2 modules we're going to talk about today, Metashape for EVO or MFE and StripAlign for EVO or SAFE, handle 2 additional functions: creating the orthomosaic from the oblique imagery that the cameras have been capturing, and if necessary, doing any geometric correction or block or strip adjustment that may be required on your LAS data. And Derek's going to go into much more detail on these. So this is where these 2 modules fit in, orthomosaic generation and geometric correction if it's needed on your project. So Metashape for EVO, if you're familiar with Agisoft's Metashape, it's a structure from motion photogrammetric package that allows you to generate ortho photos. You can also generate photogrammetric point clouds with it. We've worked with Agisoft to create Metashape for EVO, which integrates directly into the EVO workflow. It has some benefits, which Derek's going to go through in terms of allowing you to inject the actual LiDAR elevation model into your ortho generation, and has some other advantages in terms of how it handles updating image headers and so forth, some of which you can see are listed here. For both Metashape for EVO, for MFE, and for SAFE, StripAlign for EVO, we also have a new background dispatching system. Again, Derek's going to show you this, which is really good for allowing job queuing and for some of these processes, especially ortho photo generation, that can take a longer amount of time for actually generating the ortho photo. StripAlign is a solution from Basemap Solutions. It's essentially a way to do dynamic geometric correction of LiDAR data. We've worked with them to create a similar, fully integrated version that works within TrueView EVO. If you've worked with their product, or if you're familiar with it from working with other types of LiDAR data sets, it's a very powerful approach to doing this kind of geometric correction. One of the nice things is when you have it optimized, as we have for, say, our TrueView sensors, there's no parameter settings that you need to tweak. It's a very powerful tool that can take a set of LiDAR data and apply that geometric correction. And as you'll see in the demo, it's fully integrated, just as Metashape is. This is a very useful tool when you start doing larger jobs, and so you have multiple flights, multiple blocks of data that require some geometric correction to remove that final dynamic error that's remaining in any LiDAR data set. So with that, I'm going to toss it over to Derek here to actually show us these tools, much more interesting than me talking about them. Just a reminder, there is a question and answer box. There is a chat box. You can ask any questions as we go through, and we will have a little bit of time at the end to wrap up and talk a little bit about pricing and bundling and so forth. So with that, I'll toss it over to Derek here.
All right, thank you, Martin. You see my screen?
Let's see here.
Knowledge base showing here.
The knowledge, yes, I can see. I didn't realize that was the GoToWebinar, so that was my, because I always have your knowledge base up on my screen, Derek.
Oh, thank you.
No, I can see your screen, you're good to go.
All right, thank you. All right, so let's start here. We've got the support knowledge base, so support.geoq.com. It's always a good place for reference for any processing changes, things that are going on. We recently released the 2021.1.47 version of TrueView EVO. It also corresponded with a release of LP360, and there are a number of new features that have been added into the 2021.1 product. Several have been released over a couple of releases of the EVO, and some that were kind of aimed at the LP360 crowd. So there's a little bit of difference here. We're going to focus on the EVO today, and specifically on workflows surrounding with the StripAlign for EVO and the Metashape for EVO that Martin was introducing. So let me pull up EVO here. And the setup for StripAlign is really simple. StripAlign, it gets installed with the installation of EVO version 2021.1.47.0. And if you log into your Reckon account, which is now a universal login up in the upper right-hand corner, and you can, if you've got multiple that you're working with, you can even have multiple accounts in your list as long as your username and password is the same on each one. Once you're logged in, if that account has an available StripAlign license associated with it, then it will be granted at runtime. And if you don't have one, then it'll tell you if you try to run StripAlign. Or if your license is in use at the time, it'll also let you know that at that time. So there's not much involved with configuring StripAlign. Metashape is a little bit more involved, but not too much. There are what we call the Metashape for EVO, and we've been handing out licenses for this since probably about June, I think, is when the first of them started rolling out. They're a console license of Metashape, so you can't run the GUI version of the software with it. And so what we did is we install this headless version of Metashape, non-GUI version of Metashape with the installation of EVO. And in order to license it, you'll get a license key. And in your project settings, currently it's on the EXP tab, you can check your activation status, and it'll tell you whether you're activated or not, and then you can enter a key in. In order to do that, because you are making an administrative change to the machine, you have to start EVO as an administrator. So you right click on your icon, say run as administrator, and that allows you to check for the status and to activate and deactivate a license if you have it. If you do that activation, deactivation through the project settings dialog, then you're going to be using the built-in Metashape for EVO. If, on the other hand, you have a full Metashape license, or if you had received one of these Metashape for EVO licenses ahead of the software being ready for it, then you would have done a command line activation in the folder for a full or for the GUI version of Metashape. And EVO can drive both. The only difference is that if you're going to run the standalone Metashape, then there is a small package that needs to be separately installed, and you'll find that in the common files LP360 MSPy 3.8. And in here is going to be an install py YAML batch file that needs to be run with administrative privileges. It installs some additional configurations into your separately installed Metashape installation. Really nice thing about the version that's installed with EVO is that as we release new versions of EVO, there may be updates with Metashape that correspond with that, and you'll know that they'll always stay in sync. So you can always have that. If you're doing a separate one, then you always have to make sure that you're keeping current. And so currently we're running this new Metashape for EVO tool, works with Metashape version 1.7 and later. So it doesn't work with anything older than that because it uses some new scripting utilities that are only available in the latest version. All right, so in case you're not too familiar with the EVO process, I thought we'd just start with a basic, starting with a new project and go from there. I'm gonna kind of gloss over a couple steps so that we're not spending a lot of time, but we'll start with from the TrueView toolbar and the workflow toolbar. I'm going to import a new cycle. Typically, I would import and archive that directly from my UMS after an acquisition, but that's already been done. So I'm going to import in from an archive cycle. And I'm going to use a two-flight project today so they can show you some of the changes associated with multi-cycle processing in the latest version. So we've got this project root folder. This is the location I create all of my projects. I never create cycle projects. I always create projects based on the whatever the project is and put all the cycles into there. The cycle-based projects are something that we do when setting up and creating and testing systems, which is why you see the default in there. But so I'm going to just call this my safe project, my safe and MFE project here, specifically for doing an import. It's already got the spatial reference system set in the archive and has the base station for doing the processing configured. That was all done through the import. This is my coordinate. Let me bring that in. So it's going through the process of importing in that cycle and creating the features that correspond with the cycle in my project. And in that process, it has created a project as well. So I've got one cycle in my project at the moment. I'm going to go ahead and import in a second cycle into the same project. And you'll notice now it says it's importing into the current project, not a new project. So that'll bring my second cycle that covers the same project area into the same project. So I'll bring in my flight 2 here. Same kind of settings. So now I have 2 cycles in my project. And in this case, they happen to overlap, but if they didn't, they'd be beside each other, or you can get a good understanding of the relationship between the different cycles that you're collecting. But I did this so we've got an indication of just kind of how some of the changes affect some of the multi-cycle processing. So one of the things that we did add, and it's added to the LP360 project, is we've added this project manager. And the really nice thing about project manager is the table of contents can get quite lengthy with a lot of layers in it. And so I can do things like building layer groups. And in TrueView cycles, I can do this really easy by going into the build mode and then automatically building groups where it'll build them based on cycle and temporal. And the nice thing about that is when I'm in use mode, then I can toggle between the groups quite easily. And I find this handy for processing because it automatically switches my cycle flight combination based on the processing that I'm doing. And so I'm able to quickly, just move through from cycle to cycle, doing all the processing. And so I would then start making my way across the workflow. I could start the POSPAC processing wizard, go through the standard type of configuration here and picking what I need for doing processing of this particular cycle, making sure that my target frame matches my project coordinate system, that sort of thing. I've already done that on here. So I would just move on to the next step, just so that you don't have to wait for each of the pieces. And I will show you then, for example, I could do some editing of my flight lines that I'm going to be working with. I can run my trajectories, and I typically would make sure I have unique point source IDs on a per cycle basis. So I would use, typically I use like a flight followed by the flight line numbers. And I usually don't have more than 99 in a flight, so I use like 101 for the first flight. I would normally update the EXIF tags, but for the sake of showing you just a couple steps here, I'm gonna skip over that and just create the trajectories. When we're creating the trajectories, we're also updating the photo positions based on the process trajectory positions, right? And we can see that I can then move into geocoding my LiDAR, taking my imagery, all that sort of thing. I could then switch to the second cycle to process, and by just switching in my project manager, the layer group I'm working with, and that automatically switches me over, and I can start the workflow back over. To not belabor, I'm going to switch over now to a project that I have already imported. And process through each of those, including tagging, updating the EXIF tags on the imagery, and going through to a colorized point cloud. So just the standard processing on a per cycle basis, right? Once we get through to this point is where now I've processed all of the cycles for my project, and now I'm ready to look at whether I need StripAlign or not. And what I'm going to do here is I'm going to kick off StripAlign first, and you'll see here it exists on the utilities toolbar. You don't always need it. It can be helpful in a lot of cases if you do have it. And you'll see that the parameters are quite simple. We just need to specify whether we're using a layer, meaning are we making adjustments to the layer, or are we treating the layer as a fixed layer? So have we already done some processing with that layer, and we're now trying to match something to it. If I'm starting with the raw cycles, beginning of a project, then usually I'm going to be telling it to use all the LAS layers in the cycle and creating a new LAS layer off of that. This will be my safe adjusted LAS. So I'm going to be combining these multiple LAS layers from a project into a single project while doing this processing. If I was kind of doing this in a piecewise fashion, maybe collecting a few flights each day, then I might use the option where I might fix yesterday's flights that I've already done the adjustments to, and then I might append additional, the additional new LAS layers into the existing layer that I've already adjusted. So there's a couple different ways and some flexibility here in how to run it. You notice there are no parameters, so there is nothing to set here. You're allowing StripAlign itself to figure out what needs to be done. And then we do a submittal of the StripAlign job. At this point, when we go to submit it, is when it does the license check and will let us know if we have a license or not. And if we do not have a license, it'll tell us at this stage that we don't have a license. The submitting of the job is going to the job manager, and the job manager is this button that you'll see on the main, it's on the LP360 navigation toolbar, where I normally have it docked off here to the left. While the job is processing, you can see it here. You can see what the state of it is in. It tells you kind of what it's running, whether it's in progress, completed, ready for post-processing, or if it's failed. All that sort of in there. While something's running in the job manager, I can close out of job manager, I can close out of EVO, I can do other things in here. For instance, while that's running, I might want to actually start to review the data that I have in order to see, how useful this is going to be. So I might do something like, cut some profiles, coloring it by flight line. Make the profile a little bit thicker. I'm looking at one of the jobs here, and there's not a big mismatch, but there's a little bit of a mismatch in a couple of the flight lines. You'll usually find, here's a good example here. It's not very large. If I set, a 10 centimeter graticules on here, you'll see we're just a couple centimeters. I may even just go and colorize that by drape a profile in there by flight line to get an understanding. And you can see the slight difference in here. And these are just dynamic errors that'll happen, a couple centimeters as you get some differences between, the flight line solution, particularly because things like your elevation and your heading are the harder parts of the trajectory solution to tie down. So there's tends to be a little variation in those over time. And so you'll see some small variations here, and StripAlign will help us, pull this type of information together. Again, a lot of this will depend on how important it is to your processing. If it's not that big of a deal, you'll see that things line up pretty well otherwise. But this is a way to make some improvements. Part of the processing is you get an email, and an email notification goes out to a setting. There's an LP360 email notification setting under the project settings global, and that you'll get an email whenever a job gets submitted and started, and then whenever that job completes. So you don't have to sit there monitoring the task of the job manager, and you'll be able to see the process on that. You get notification on it. The other thing you'll see is when it's flashing with the check mark, it means some job is finished on some project, and we'll see here my processing is finished already. It took about 1.5 minutes on that particular one that I was running. All of the jobs that get submitted to the job manager so far in terms of the StripAlign for EVO and the Metashape for EVO, they produce outputs, and we want those outputs to be able to come into our project. And so in the case of StripAlign, we produce a new LAS layer of adjusted LAS files. We don't adjust anything in place, we adjust it afterwards, which makes it really nice because then you could do some comparisons of before and after. You can see whether it's improving your data set or not, and how it's improving your data set, and make some decisions as to whether you're okay with that. So the post process allows us to run these jobs, and we can queue them up and put several of them into the queue, and only one of each job type will process at any point in time. So you don't have to worry about getting conflicts with, say, 2 Metashape processes trying to hog all the resources, and then they both stop working. And if you have a lot of processing to do, several different projects, it means you can queue things up and get them into the job queue. And as resources become available, when one MFE process stops, the next one will start, or when one's safe processing stops, the next one will begin. So it allows you to queue up and do some other processing. So once it's completed, we can select our project. If we're in the project already, you'll see the open project is grayed out. We're already in that same project. Otherwise, you can click open project because we don't even need to stay within the same project that's processing in the background in the job manager. But once we're in our project, then we can post process. And post process will then run the post processing steps. And for safe, that means I'm going to add a new LAS layer to my project. So we've taken the output from StripAlign for EVO, and it's created a new LAS layer in here now. This is my safe adjusted LAS layer. It's made it the active LAS layer because I have the single LAS mode on. It is the view that I'm seeing here in my profile view. So we can see I can toggle between the active LAS layer. This is one of the 2 cycles prior, and this is the combination of all the cycles after. And you can see how well it's brought those together. To make it a little bit easier to look at, I will show you one other thing while I'm in here. Is we have 2 LAS files. If I wasn't processing in the safe, if I wasn't using safe, we've added in a merge LAS layers, so you no longer have to go to a separate project for working. And I'm going to merge these LAS layers just for the sake of making it easier to compare all the flight lines. So this is my combined LAS. When you're using safe, we don't need to do this because safe is going to combine them into a single layer for us. But for the purpose of evaluating the differences between the safe processing and our original LAS strips, I want to merge them together here for you. So that way, instead of having 2 cycle LAS files, we'll now have a single combined LAS file. And so I can toggle between the safe adjusted and the combined LAS. You can see the difference there. Even in a project area here where the differences are small, it's making a couple centimeters of adjustments to tighten up the data set a little bit. Let me switch to a different project. So I'm going to open up Project Manager here, go to Projects, and I'm going to open up a project where I've done this processing on it. So it's had the same StripAlign for EVO run on, but I've also taken and I've used the export wizard here to export out some point insertion images, and I did them at a 0.5 meter and just did them as DZ images, and I just used a 2 centimeter because I wasn't seeing very much. I wasn't seeing a large amount of variation in these particular cycles. So I just used a 2 centimeter coloring to generate up some DZ images. And I did the same for before and after. Yeah. So this is one of the flights before, and we can see a little bit of variation where the green is fitting within 2 centimeters, yellow is within 4, orange is within 6. Red, you're seeing where there's trees and around the edge of the buildings, because what we're doing is comparing the highest and lowest of different point source IDs within that grid cell. And so this is kind of standard mismatch, DZ images that we look at in LiDAR analysis, just to see how well things are fitting. It can give us an idea of where to look for some of these changes. So for instance, this is my single LAS, and if I switch then to the StripAlign, we can see the match result. And if you want to see, this is the difference. So this is the DZ image from the safe adjusted LAS data. So we go from a little bit of some small mismatches to a much tighter data set. Okay. The next step in the process then would be to smooth our data. Right, so we typically would use a point cloud task, where we can use a smoothing point cloud is the task type. And I would run that out to tiled files, where there's 2 things going to be accomplished here. One is, if we have longer flight lines, then EVO is going to create smaller files, and it likes smaller files rather than single large files much better. Its performance is better with those. And if I run this, it takes about 2 minutes on this data set, so I already did that here. And if I zoom in a little bit here, we'll see that once you smooth this TrueView 515 data, even after the safe adjustment, then it will help bring that noise that you get from these lower grade automotive type of laser scanners and reduce that in the data set. So a really nice thing about all this is if we look at some control for the data set, and if I look at this, I'll look at this on the, I'll look at it on one of the flights first. And I'll just use an IDW here because of the data density. We'll see we have a little bit of a bias in this data set, a very small, as said, standard deviation of the mean. If I run the same on the safe adjusted LAS, you'll see that it remains the same. So it's not going to move things off of your control. It keeps things centered where they are. All right. So then we go through the process of, in this case, I would debias the data set, run through, some ground classification, and do some manual classification. That starts to get me where I'm ready to look at the Metashape for EVO, and that's because I need a digital elevation model. So let me switch over to a project where I've got things adjusted here. So I did a little classification. You can see I ran ground classification. That's because we get a much better orthomosaic if we've done a classification, and that doesn't take very long just to do a quick one. It takes about a minute on a project on this, which would be about a cycle's worth of data of And then I've done some additional manual classification of the building surfaces, because I'll get a better looking ortho if I've cleaned, if I've done some other classification for those types of non-ground features such as buildings. We could go a step further and put some vector elements in here using some of the feature edit tools within EVO, and that would really give us some sharp edges around features. But this will be sufficient for a pretty quick ortho. So we need to have a digital elevation model. And one of the things we want to do with a digital elevation model is when you have overhang, you tend to have some spots where the ground is underneath the roof. And so we tend to use a classify by statistics, where I'll use maybe a 5 centimeter size and tell it just give me the maximum point. So out of my building, roof, bridge decks, and my ground classes, give me the one that's at the highest elevation. That's the one the ortho is going to see. I'll run that on the data set, and then that allows me to then export out a It allows me to export out a digital elevation model. So in this case, I'm going to do an elevation, a geotiff, and that's coming off of the ground, building, or bridge decks, where the what I did when I classified the maximum is I just threw a synthetic flag on it to say, hey, this is the maximum point that's within that cell. So I just want those maximum points. You can run that out for the extents of the LiDAR data. And this will be my trying to dem for my ortho. We'll insert that into the map. So when we go to do the processing with Metashape for EVO, then we need we want to have a digital elevation model, because if we have Metashape create the model, it takes a while for it to create a point cloud off of the imagery and then make use of that. And you don't have any control over that. Whereas here we get to generate up the the elevation model pretty quickly off of our LiDAR data. And we can classify it and clean it and make adjustments. We can add vector elements. So there's a lot we can do to adjust the elevation model. And the elevation model plays a big role in how the ortho mosaic rectifies. So we always want to use that. The other piece that we want are the photos, right? And so through the processing, we have taken our nav quality photos and we have tagged them with INS, meaning that we've taken and we've post-processed the trajectory solution, in this case using an INS, as it's a 3DIS system. And so we've improved the quality of those position and orientation. It used to be that we would use an export photo package and we would create a copy of these images that are just the ones we want to retain. So you notice I'm looking at the retaining. So I'm not looking at the full, not looking at the full set of images, which includes kind of the ends and the landings and takeoffs. I'm just looking at the retains. So we would normally export that out, and then you could, you used to use this old create ortho from photo package tool. What we've done is with the Metashape for EVO tools, we've integrated this even tighter, so there is no need to create a photo package anymore. What you do is you just run Metashape for EVO, and you pick the layer or layers. If you want to use all of the retained photos from all the different cycles, you could do that. And you pick your ortho that you're going to run, your DEM that you're going to use for generating the ortho. You give it a name, and then you can submit the job. And it's pretty much that simple. The a priori is we have some information on the position and orientation of the images. And when Metashape does the bundle block adjustment, if it can't adjust some of the images, it would normally just leave them out, and you would end up with some holes in your data set. And what EVO tries to do is when the adjustment gets done, then it's going to look for any of the images that didn't get adjusted, and will substitute in at least the a priori EO information. And that helps minimize any holes in your resulting orthophoto. There are other options on here. The default is what we use with the 3DIS system, which is we're going to generate an elevation model. We're going to feed that in. For in Truvo EVO, we also support our 2DIS systems, which are just photogrammetric only TrueView systems. So you don't have an elevation model to start with. And we also support guest sensors such as DJI's P4 RTK and the P1 on the M300 RTK system. So in those ones, then you would need to generate a point cloud and create the ortho where you're generating both of those from the images. Then you're just deciding, normally you'd always decide I'm keeping my ortho, and you just decide if you're going to keep that point cloud that gets generated as well by the process. And if you do, then you need to give it a LAS layer that's going to go to. But that's only when you're dealing with imagery only systems, because we don't need to generate that point cloud when we have our LiDAR data. Right? The other options you get on here is there are some advanced settings, and these are settings that you may desire to change. Though we default them to our recommended settings, such as we always recommend that you use the sensor fix calibration. So this is the calibration that is done and posted to Reckon for your system. And that's the camera calibration values. And we allow that, we want to keep that fixed so that we don't need to use ground control in our processing. That way we can just use checkpoints to verify that things are falling where they need to be. There are some other settings like alignment accuracy. We default to high. There's some trade-off in speed and the accuracy of the alignment depending on which settings you use. So that's why we default to a high setting here. If we are doing a 2DIS, so a camera-only system, then you might be generating a point cloud. And if you're generating a point cloud, then you also have some options in terms of the quality of that point cloud, the density of the point cloud. And we want to tile the point cloud, especially if you have some fairly large projects, because we want to make sure that we keep the size of our LAS files down so that they're easily manipulatable and work very efficiently in EVO. There is an option to add Metashape extra bytes. Extra bytes is a big new thing that was added into LP360 in the 2021.1 build, and we really can make use of that, especially when you're doing ground classification of this image generated, dense image matching point cloud. We can use that extra byte information to tell which ones are higher confidence that they're probably a valid point versus ones that are just noise. When you're generating an ortho, we have options for our compression. We recommend a JPEG compression. If you're doing JPEG compression, we recommend doing quality level 90. You do have the options for your background color. And then we recommend to use the optimal GSD from the images, where you let Metashape decide what is the best ground sample distance for your images. But if you have a preference, say you wanted specifically to have a 5 centimeter ortho, then you can go in here and you can set the value. So you just deselect the optimal GSD and set the value in here, and that's going to be in the ground units of whatever your project happens to be in. So I'm working in meters here. If I put 0.05, I'd be getting a 5 centimeter result out. So again, we would submit the MFE job. Oh, switch my setting over here. and then that would start processing. This would take, this one here takes about 20 minutes for this particular, actually probably, I think I picked both of them here, probably would take about 40 minutes on this particular project to run on my machine. So I'm just gonna actually cancel that one off, and I'm gonna switch to a project where I've already processed, so you don't have to wait through the end of the hour for it. So let me go to a project where my oh, actually I can do that from here. Sorry, let me show you in Job Manager. I previously did the processing on a project, the same sort of project here. You can see it's ready for post-processing. And when I select it, I can see the option to open the project. I also have, I should have mentioned this with the SAFE as well, but you also have the option to look at the log or the report. So with SAFE, you just get a log, and a SAFE log will have some information, you know, in terms just some basic information of what ran, and if there are any error messages in there. I usually just look for the standard error section. There's some normal warnings in there, but other than that, everything runs fine. With Metashape for EVO, you can look at the report, and the report's going to bring you up your standard Agisoft Metashape processing report, where we can look at how well the camera positions and orientations were for that project when we held the camera calibration. So let me switch to the project where I did this processing, so I can show you the post-processing steps. So I've now switched to my processed project, and sorry, keep clicking the wrong button. Now I'm in the post-processing project, then I can run the post-process step. And you'll notice here, what it's going to do is two things. We're going to add the ortho layer. Since I did this from the 3ds system, I don't have any point cloud. I'm just adding an ortho. But you'll also see this where it says I'm going to update the photo EOs with BBA. That means I'm also going to get updated position and orientation information based off the bundle block adjustment done in Metashape. And when I run this, I'll show you that as well. So it's going through and it's updating all the photo EXIF tags with the new information. So I've got two things now. I have my ortho mosaic. So I've got my Triano ortho, there it is there. All right, that's been generated off of the data. And I also have, if I look at my retained photos, I'll see that the position and orientation quality has been updated. So I now have the bundle block adjusted values that are in here. Where that becomes really important is if you're using a tool we added at the end of last year, which is Image Explorer. Then with Image Explorer, if I pick a feature on the ground, say my control point, I don't know what I did to it. Oh, I know what I did with it. I've got the wrong tool going. There we go. Then it's going to show us the images that best see that data. And so that's whether I look at a feature, or I could also look at LiDAR data. Let me turn off in my table of contents, just the ortho, and turn on my point cloud. You can see here's my roof of my building. And so because I've got the bundle block adjusted angles and positions, then the images will pull up better as to which ones match and which ones see the particular feature that I'm looking for. I didn't do a very good job in picking a feature for you, but hopefully that gives you an idea. So we kind of get two things out of this process: is we get that updated image positions and orientations, plus you get the nice ortho, where we get some good quality in the vegetated areas off the northeast there that was getting out. We have kind of our true ortho, where we've used the point cloud to give us the roof of the building. There can be some issues around the edges because I'm using a point data set, and that's where I said if we put some vector elements in here, we can clean this up and make this a little cleaner along the edges of features. Same thing happens when you get things like retaining walls. Sometimes you get some digital elevation model that kind of spans across that, and so it gives you a chance to put in some, hold that surface a little nicer. I was taking a moment to load there. There we go. Right, so that's our ortho image. Now, a couple things here with the ortho image. When we generate an ortho image through Metashape for EVO, just like we did with the create ortho, we always create that as a big TIFF. We don't know how big of an image you're going to generate, and it's always safer just to create a big TIFF. Problem with a big TIFF is Civil 3D can't read them, and so you might have to convert it. We give you a tool, and the tool I use for that is actually our reproject raster point cloud task. And the reproject raster point cloud task can be run without doing an actual conversion. Right? I've unchecked the convert here, and then I can create a clipped ortho, and I can do that by either digitizing, some sort of boundary that helps me clean up the edges, or I can use my project boundary if I've already got a feature file, a shape file that has that information in it. Or what I could also do is I might use the grid generator point cloud task to create an index, because if you get some really large files, the difference between big TIFF and a normal TIFF is, you can't have a normal TIFF that's bigger than 4 gigabytes in size. So if you get some really large images, you've got to start blocking them up into tiles. Otherwise, you're not going to be able to get them into CAD. So this utility, this reproject raster, allows you to do that. So you kind of have two different functions here: one to be able to clip it into grid, one to be able to clip it to a boundary, or you can actually do both at the same time. So there's a couple different things you can do with it. I'll show you the example of one that I did earlier, and that is I used the clipping option, and I just clipped that back to a boundary, right? And two things that come out of that is you get a regular TIFF, so it's no longer a big TIFF, so it'll go into Civil 3D just fine. Plus, you can clean up the edges of your ortho mosaic, where you would normally have drop off as you get to the edges, and depending what your digital elevation model is doing. Right, so a few different things that you can do in there. So that's a quick little introduction to a couple of the changes in the workflow, and really highlighting here how the StripAlign for EVO can be used for helping to better align, geometrically correct the dynamic positioning errors that are between your strips or flight lines of data, and then how you can take and do some automatic generation of the ortho mosaic using the output from your LiDAR data and your imagery to create that ortho mosaic, and then be able to clip that or modify that for use in your CAD software. They both make use of the job manager, and hopefully soon we'll be adding a few more things to the job manager, which is really nice because it helps you queue up different projects. And like I said, you don't even need to be into EVO. It is a background process that runs, so the only thing is you can't log out. You can lock your machine. You can close out of EVO. You can close out of the job manager. You just can't log out of the machine or restart it. But other than that, it'll queue up and keep processing overnight for you. All right. questions there, Martin?
Yeah, we have a couple of questions. I think we've got a little bit of time left. We will just wrap up at the top of the hour. I'll go through pricing and availability. But we have a couple of questions. First, most of the data you were showing today, in fact, all the data I think was TrueView 515. Is that correct?
That's correct. Yeah, this is 2 cycles from one of our TrueView 515s.
Okay, so first question is really about StripAlign. Does it correct horizontal as well as vertical? So can you talk a little bit about what it's correcting when you go through that?
Yes. So it's looking at the dynamic errors within your trajectory solution, and that's going to be both position and orientation. And so the majority of that's going to be elevation biases between flight lines, but there will also be things like horizontal adjustment that's coming from adjustments to the heading error within some of the data sets. And so you will see horizontal adjustments, you'll see alignment, better alignment of some of the features. Um, this one didn't
Okay,
have a whole lot with it, but it did have some.
right.
You can see some better alignment when you looked at things like the roof line here.
Okay, great. And then just in terms of workflow again, you did the strip alignment and then did smoothing. That's the recommended flow. You wouldn't want to smooth before doing strip alignment?
Correct. Yeah, we always want to do the strip alignment first. The if the smoothing is going to look at basically over all the data is and then try to fit it, and so you want to get it to best fit first before you do the smoothing.
Gotcha, gotcha. I'm not sure we have time. There's been a couple of questions just about the workflow for generating the DEM because you did some statistical thinning and so forth. Is that available on the knowledge base, or do we have a more detailed write-up of that workflow? There were a couple of questions about generating the DEM.
Yes, if you look in, so I've tried to put some extensive recommendations within the EVO users guide. So this has been updated for the new release. And part of that is a section in the MFE section, which will talk about the elevation model. There is a write-up in here that talks about the digital elevation model and the different recommendations from doing a very quick elevation model to actually doing a little bit of classification, doing some manual classification, maybe doing some above ground features or bridge deck classification if you have those, or even going so far as creating some brake line elements to even make that better. And includes a section on some recommendations for how to do run the statistics point cloud task in order to get a better elevation model out of those. Try to give that as a step-by-step process.
Right. Okay. So there is information on the knowledge base, and again, everybody will be getting a recording of this. We do have some more questions, but since we're coming up to the top of the hour, what I'm going to do now is just wrap up a little bit on pricing, availability, and bundling. And then Derek and I will stay on after the top of the hour to answer some more questions. But let me just hop back over to my screen. I should be able to. And I should be able to show this screen here. Okay. Yeah, so just to wrap up, so Metashape for EVO, MFE, and StripAlign for EVO are both add-on modules for the EVO workflow. They're both priced at $2,500, as you can see here. Both will work with any of the TrueView sensor models, but there are a couple of points to just go through. So for MFE, it is available for all sensor models. You can use a full Metashape Pro license, which we're an Agasoft reseller, so you can purchase through us, or you may already have a full license. It's about just under 3,500, and not use MFE. So we're very tightly integrated with that workflow. If you have a full Metashape Pro license, you can use that instead of MFE. If you're a subscription user, if you're renting a TrueView system, then you do have to use the Metashape Pro, the full Agasoft license. There's no rental version of MFE. StripAlign is also available for all sensor models. However, we don't have the same interaction. You can't use a full StripAlign license should you be one of the people that have those. It's not compatible with the EVO workflow. So to run StripAlign in EVO, you do need a safe license. And it's not available currently for subscription users. We're working with BaseMap on that. Hope to have a solution there for subscription users in the future. But currently, you don't have access to safe if you're a subscription user. And then in new sensor purchases, new hardware purchases, we are going to bundle MFE and safe for new sensor purchases. You can talk to your sales rep about that and get the specifics on that. If you're in the market to purchase a new sensor, talk to your sales rep about MFE and safe for that. I'll just put up a little reminder here, and then we'll get back to the Q&A. We do have a webinar coming up in a couple of weeks, Monday, November 15th. We're going to do a full update on the product portfolio. We have some exciting new model announcements we're going to be making, along with some other interesting additions we've been making to the whole TrueView ecosystem. So if you're not signed up for that, I would recommend please do so. Please join us November 15th. We've got some interesting announcements there. So with that, as I said, Derek and I are going to stay on and look at answering some of these questions, but there will be a recording of the full webinar that's, you'll get a link to that in the next day or two, so you can review or share with your colleagues. So thanks for your time, and let's just see where we're at with the Q&A. Looks like we've actually covered off most of these. There is a question here, Derek, about accuracy. I don't know if you want to take that one, just in terms of the overall accuracy you can get. In this case, we're talking about a 515 data set.
Sorry, I was muted.
I was going to say, hopefully my colleague didn't. Yeah, that's okay. Yeah, go ahead.
So we're typically seeing, 2 to 5 centimeters, depending on what we're looking at. But normally we say, like with a 515, you're normally seeing better than 5 centimeters at 1 sigma, or network accuracy of better than 5 centimeter RMSE. Of course, with the Regal line, the survey grade line of scanners, they're a lot higher grade scanner system, and so you're typically seeing 2 to 3 centimeters on those.
Right.
Of course, that's our specs, and we normally see better than that when you actually process.
Right. Yeah. There was a question here, and I will just mention it because we do still have a few folks that are with us. So StripAlign, and in fact, geometric correction procedures like this are generally adjusting the data to remove remaining dynamic error in the data set. So SAFE or StripAlign in general, or even some of the other tools out there like TerraMatch, they're not propagating those corrections back to the trajectory. That's just an important note to know if you're diving that deep into it. We're essentially correcting the dynamic error that's in the data set. Okay, so with that, there are a few other questions here. I think we've covered the accuracy, we've covered this. Safe bundling with ongoing maintenance. Yes, there will be a maintenance package for SAFE and MFE if you bought them separately. I'm not sure at the moment. I'll find out and get back to those that have asked about where that fits into the annual, if you've got the full service maintenance package, where that fits in, but we can get you some details on that. So with that, we'll go ahead and conclude. Again, thanks everybody for joining us today, and thanks to those of you that have stayed on a little later for our extended Q&A. As I've got up here on the screen, do join us on November 15th. We've got some exciting new model announcements and some exciting announcements about the whole TrueView product line. So we hope to see you then. Thank you and goodbye.